Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter current electricity. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. And in any other chapter of physics, if you have more difficulty, then please mention the name of that chapter also in the comment section so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions based on previous year KCET exam will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it has been told that a wire has a resistance of 6 ohm. It has the resistance 6 ohm. It is cut into two parts. It is cut into two parts, and both half values are connected in parallel. So these two parts are connected in parallel. So it means that here we know that R equals to rho L by A. So R is proportional to L. So if it is cut into two parts, so then each will have resistance 3 ohm. Since when length is halved, the resistance will be also halved. So these 3 ohm resistances are connected in parallel. So therefore the R equivalent will be equal to 3 into 3 by 3 plus 3, that is 6. So 3 to the 6. So this is 3 by 2, which is 1.5 ohm. So option 2 is the correct answer. Then it is told two electric bulbs A and B are rated as 60 ohm, 60 watt and 100 watt. They are connected in parallel to the same source. They are connected in parallel to the same source. This is bulb A and bulb B. So bulb A has rating 60 watt, bulb B has rating 100 watt. They are connected in parallel to the same source. This is the voltage source. Okay. So then uh, both draws the same current. A draws more current than B. So okay, that we have to find. So they are connected to the same source. The applied voltage is suppose V. So let's say this is P1, this is P2. So the resistance of the bulb A, that is R1, and suppose the resistance of bulb B, that is R2. So then R1 we will tell that is equal to V square by P1, and R2 will be equal to V square by P2. Since we know that P equals to V square by R. So now, uh, so how much current will pass through the bulb A, that is suppose I1, and how much current will pass through the bulb B, that is I2. So we know that I1 is to I2. Uh, it means the ratio of the currents flowing through A and B, that will be equal to V by R. So now since the voltage across both the bulbs is same, so the current will be in the ratio, the inverse ratio of the resistances. So 1 by R1 is to 1 by R2. So now it means, so 1 by R1 I can say that is equal to V square by, so sorry, that is P1 by V square, and 1 by R2, that will be obviously P2 by P2 by V square. So therefore this will be equal to P1 is to P2. So it means that I1 is to I2 also will be equal to P1, that is 60 watt, is to 100. So that is equal to 2 3 are 6, 2 5 are 10, so 3 is to 5. So therefore A will draw less current than B, or I can say B draws more current than B. B draws more current. Since why, here we can see that I2 is higher than I1. Since I1 is to I2 is 3 is to 5. So of course B draws more current than the bulb A. So option 3 is the correct answer. So then here it is told an unknown resistance R1 is connected in series. Unknown resistance R1 is connected in series with a resistance of 10 ohm. This combination is connected to one gap of a meter bridge while a resistance R2 is connected to the other gap. Here it is R2. So here this is the meter bridge, suppose. So here we have the balance point. This is the galvanometer. This is the galvanometer. So the balance point is 50 centimeter. Balance point is 50 centimeter. And so the remaining will be also 50 centimeter. Since why in a meter bridge, the length of the meter bridge wire is 1 meter, means 100 centimeter is the length of the meter bridge wire. Length of the meter bridge wire. So here we have the balance point. Now, therefore, now when the 10 ohm resistance is removed, the balance point will shift to 40 centimeter when this one is removed. Okay. So therefore, we can say that R1 by R2 that will be obviously equal to this, means R1 plus 10 ohm by R2, that will be equal, that is equal to the ratio of these two lengths, that is 50 centimeter by 50 centimeter. Since why here the resistance per unit length, that is constant R naught, which is R by L, resistance per unit length, that is equal to constant, means R by 100 centimeter, that is constant here. So it means resistance of the wire, of the meter bridge wire, is directly proportional to the length of the balance point. So this is 1. So therefore R1 plus 10, that is equal to R2. And also here, when 10 ohm is removed, it means that then R1 by R2, then the balance point is 40 centimeters. So it will be 40 and the remaining will be 60. So this will be 2 to the 4 to 3 or 6. So this is, so 3R1, that is equal to 2R2. So we have to find out R1. So R2, I can say that is equal to 3R1 by 2. So therefore, we can say that R1 plus 10, that is equal to R2. R2 equals to 3R1 by 2. 3R1 by 2. So therefore, 3R1 by 2 minus R1, that is equal to 10. So of course, R1 by 2 equal to 10. So R1 equals to 20 ohm. R1 is 20 ohm. So option 3 is the correct answer. Then here it is told that in the circuit shown, the internal resistance of the cell is negligible. The steady state current in the 2 ohm resistor. So here we have to find how much current will flow through this 2 ohm resistor. So let's say I1, that we have to find. Now here this is 3 ohm and here one capacitor is placed, so it will become fully charged after at steady state. At steady state, here it is told the steady state current. It means at the steady state, um, the capacitor will be fully charged. Capacitor be fully or completely charged. So it means through the middle branch where the capacitor is being connected, so through this no current will pass through. It means through this branch no current will flow. No current will flow. So it means that we can simply remove this middle branch. So therefore, this the equivalent circuit will be like this only, 2.8 ohm. and this EMF of this cell is 6 volt. So now we have to find how much is the total current. So the equivalent resistance of this circuit, that will be equal to 2 into 3 by 2 plus 3, that is 5 plus 2.8. So since these two are connected in parallel and this branch is connected in series with 2.8, this is 2 3 6, 6 by 5, that is equal to 1.2 plus 2.8, so that is equal to 4 ohm. So therefore the net current that is flowing in the through the cell, the net current which is flowing through the cell, that will be equal to I equal to E by R equivalent. So that will be equal to 6 by 4, that is equal to 3 by 2 ampere, so 1.5 ampere. Now, how much current will flow through the 2 ohm resistance? So that will be equal to I1 will be equal to I into, so the current will be distributed in the inverse ratio of the resistances. So it will be I into 3 by 5, 3 by 3 plus 2. So it will be 3 by 5 into 1.5. So that is 3, 5, 3 are 15. So it is 0.9 ampere. So 0.9 ampere will flow through 2 ohm resistance, and the remaining, which is 0.6 ampere, will flow through 3 ohm resistor, and 0.9 ampere will flow through 2 ohm resistor. So option 1 is the correct answer. The magnitude of I in ampere unit is, this is 15 ohm, this is 5 ohm, this is 60 ohm, this is 10 ohm, this is 1 ampere, okay. The So how much current will flow through this 60 ohm resistor, that we have to find. So the R equivalent here, the these three resistors are connected in parallel, and these two 15 ohm and 5 ohm are connected in series. So their equivalent resistance is 20 ohm. So 20 ohm, 10 ohm, and 60 ohm are connected in parallel. So the R equivalent will be 1 by 60 plus 1 by 50, 1 by 20 plus 1 by 10. So this will be equal to 1 by, this LCM will be 60. So this is 1 plus 3 plus 6. So 6 plus 4, that is 10. So this is equal to 60 by 10, that is 6 ohm. So therefore, so how much current will flow through the 60 ohm resistor? So we know that current is distributed in the inverse ratio of resistances. So therefore, I will be equal to 1 by 60 divided by 1 by R equivalent. So that will be 1 by 60 divided by 1 by 6. R equivalent is 6. So this will be equal to 6 by 60. So that will be equal to 1 by 10. So 0.1 ampere. 0.1 ampere will flow through this 60 ohm, and through the 20 ohm resistance, how much current will flow? It will be 1 by 20 into 6. So that will be 3 or 6, 2, 10. So to this branch, to this branch, 0.3 ampere current will flow, and the remaining, which is 1 minus 0.4, that is 0.6 ampere current will flow through the 10 ohm resistance. Since it will be 1 by 10 into 6. 0.6 ampere. Okay. Since why the rule is less current flows through greater resistance, and if through that branch where the resistance is low, through that more current will flow. More current will flow through less resistance, and less current will flow through more resistance. And this rule is applicable only when there is parallel connection. When there is parallel connection, then only it is applicable. If the potential difference across the internal resistance R1 is equal to the EMF of the battery, then the potential difference across the internal resistance R1. So here it has been told that across R1, it means across this, the potential difference is same as E. So then what is the relation in between R and R1? So therefore, to this, how much current is flowing? The so this is also E, this is also E, this is R2, this is R. So this I current is flowing like this. This is R. So I will be equal to the equivalent EMF, that is equal to 2E divided by R plus R1 plus R2. And so the voltage or the potential difference across R1, let's call it as V1. So V1 is given as E. This is given. So then we have to find the relation in between R and R1 plus R2. Okay, so V1 is equal to I into R1, I into R1, that is equal to E. So therefore I into R1, that is 2E into R1 divided by R1 plus R plus R1 plus R2, that is equal to E again. So E and E will cancel out. Then we can say R plus R1 plus R2, that is equal to 2R1. So therefore R will be equal to 2R1 minus R1 plus R2. So R will be equal to R1 minus R2. So option 3 is the correct answer. Then it is told by using only two resistance coils singly in series. By using two resistance coils singly or in series or in parallel, one should be able to obtain resistances of 3 ohm, 4 ohm, 12 ohm, and 16 ohm. The separate resistances of the coils are by using two resistance coils singly or in series. Okay, so here we have to form 3 ohm, 4 ohm, 12 ohm, and 16 ohm. So here we can use 4 ohm and 12 ohm. Since why? If we connect 4 ohm simply, then we will get 4 ohm only. Since we have to connect two resistances, either singly we can connect, or in series we can connect, it has been told, or in parallel we can connect. So 4 ohm I can connect singly, then I will get 4 ohm. And if we connect 4 ohm with 12 ohm in series, then the R equivalent will be, the equivalent resistance will be 16 ohm. And if we connect 4 ohm resistance with 12 ohm in parallel, then the equivalent resistance will be 4 into 12 by 4 plus 12. So that will be equal to 12 4 is 48, 48 by 16. So that is also 3. 3 ohm we will get. And if we connect only 12 ohm singly, then we will get 12 ohm. So it means by using only 4 ohm resistor and 12 ohm resistor, we can obtain all these four resistances: 4 ohm, 16 ohm, 3 ohm, and 12 ohm. So therefore, option 2 is the correct answer. Then it is told in the given circuit, the voltmeter records 5 volts. The resistance of the voltmeter in ohms is. So here it has been told that it is uh, it is recording 5 volts. So then it means that across, so the two resistors are connected across 10 volts. So across 50 ohm also the voltage is 5 volts, and the voltage across this 10 ohm resistor has been also, no, the voltage across this 100 ohm resistor is also 5 volts. So it means the equivalent resistance of this voltmeter and 100 ohm should be also 50 ohm. So therefore, if the resistance of the voltmeter is suppose R, so then therefore we can say that R into 100 by R plus 100, that will be also equal to 50 ohm. Since why, if these two resistances are same, if the 100 ohm, if if those two resistances are same, then only same voltage will be across these two. It means if same voltage is across these two resistors, so it means if this one is 50 ohm, then this, the equivalent resistance of this part also should be 50 ohm only. So therefore will be 100 R, that is equal to 50 into R plus 100. So therefore 50 I can cancel with 100, so that is 2. So 2R is equal to R plus 100. So R also should be equal to 100. So the resistance of the voltmeter should be 100 ohms. So option 2 is the correct answer. Then here it has been told that a 5 ampere current is set up in an external circuit. 5 ampere current is set up in an external circuit by a 6 volt storage battery. A storage battery is there of 6 volt. A 5 ampere current is being set up for 6 minutes. The chemical energy of the battery is reduced by. So therefore, the chemical energy that is reduced, or I can say the chemical energy that is consumed by the battery, so that will be equal to V into I into T. Means V V means the voltage across the battery, that is E. So E I into T. So E is 6 volt. 6 volts into the current is 5 ampere into the time is 6 minutes. So we should convert into seconds. So this will be 6 into 60 seconds. So 360. So this much joule it should consume. So this will be 6 5 is 30. So 360 into 30. So that will be 6 is 18, 3 is 9, 10800 joule, or I can say 1.08 into 10 power 4 joule. So option 1 is the correct answer. Then the current in a simple circuit is 5 ampere when an additional resistance of 2 ohm is connected. So let's say the EMF of the cell is E, and it has got resistance R initially. So this one when this 2 ohm resistor is not connected, when this 2 ohm resistor is not connected, so then the current initially I1, it was E by R, which was 5 ampere. And then when an additional resistance of 2 ohm is connected, the uh, current drops to 4 ampere. So it means the new current will be E by 2 plus R, and that is equal to 4 ampere. Then the original resistance of the circuit in ohms was, means R we have to find. So therefore from here we can say that E is equal to 5R. So therefore we can say that 5R divided by 2 plus R, that is equal to 4. So therefore 5R will be equal to 8 plus 4R. So therefore R will be equal to 8. So it means that the original resistance of the circuit is 8 ohms. So option 2 is the correct answer. Then here it is told in the circuit given E equals to 6 volt, R1 equals to 100 ohm, R2 is R2 and R3 are same, which is 50 ohm, and R4 is 75 ohms. The equivalent resistance of the circuit is. So therefore here we see that this this R1 is connected in series with R2. R1 is 100 ohm, is 100 ohm, and this is R2, that is 50 ohm, and this one is again R4, which is 75 ohm. Then here one more, that is R3, which is also 50 ohm. So these three are connected in parallel. These three are connected in parallel. So therefore the R equivalent for these three, that will be obviously 1 by 50 plus 1 by 50 plus 1 by 75. And this the these three are connected in series, means the equivalent of these three is again connected in series with 100 ohm. So this plus 100. So this will be equal to 1 by sorry, this will be 1 by 50 plus 1 by 75 plus 1 by 50. So this will be the LCM of 50 and 75, that is 50 and 75 LCM, that is equal to 5 tens of 5 15s of 5 2s are 10, 5 3s are 15, so 30 150, 150, and then 5 3s are 15, then 75 2s are 150 plus 53s are, so 3 plus 3 6, 6 plus 2 8, so plus 100. So this will be equal to 150 divided by 8 plus 100. This will be equal to 100 plus 8 to the 16. So I can say 8 ones are 8. So 150 divided by 8. So this is obviously 8 ones are 8. Then 7, 70. So 9 is 8 is 64. Then 60. Then 8 is 64. 7 is 56. Then 5 8 is 40. So it will be 18.75. So this will be 118.75 ohms. 118.75 ohms. So option 3 is the correct answer. Then here it is told two resistances are connected in two gaps of a meter bridge. Two resistances are connected the two gaps of a meter bridge. So let's say this is R1, this is R2. And here we have the meter bridge wire. So here through this, the galvanometer is connected to this. So here is the balance point. So this is 20 centimeter. So the remaining part is 80 centimeter. So here we have this zero end. This is the zero end. and a resistance of 15 ohm is connected in series with the smaller of the two. So here, let's suppose R1 is less than R2. So with R1, another another 15 ohm resistance is connected in series with this. Means, let's say here it is R1, here another 15 ohm is connected. So then the balance point shifts to 40 centimeter. The null point or the balance point shift to 40 centimeter. So then the value of the smaller resistance in ohm is. So initially when this 15 ohm was not connected, so then we can say that R1 by R2. So then the balance point was 20 centimeters. So R1 by R2 will be 20 by 80. And finally, when the 15 ohm is connected with R1, since R1 is suppose the smaller of the smaller resistance among R1 and R2, since of obviously R1 will be less than R2 only, since why R1 is to R2 is 1 is to 4. R1 is to R2 is 1 is to 4. So R2 is obviously higher than R1. So finally, when 15 ohm is connected in series with R1, then R1 plus 15 by R2. So R1 plus 15 will be the equivalent resistance at this gap. So this by R2, that is equal to 40 by 60. Since the new null point is 40. So this will be 2 to the 4, 2 3 is 6. So the value of the smaller resistances means R1 has been asked. So from here we can see that R2 equals to 4R1. R2 equals to 4R1. So therefore we can say that R1 plus 15 divided by 4R1, that is equal to 2 by 3. So therefore I can say 3R1 plus 15 is a 45, that is equal to 8R1. So therefore 5R1, that is equal to 45. So R1 equals to 5 nines of 45, so 9 ohms. So option 3 is the correct answer. Then here it is told, in an ammeter, 10% of main current is passing through the galvanometer. It means the galvanometer has got a resistance of Rg, and no, the resistance of the galvanometer is G, they are saying. Resistance of the galvanometer is G. The resistance of the galvanometer is G only. And a shunt resistance is connected, Rs, with in parallel with the galvanometer. Since why through galvanometer only 10% of the main current should pass through, and through the shunt resistance 90% of the current should pass through. It means this whole thing is called as an ammeter. When the galvanometer is connected in parallel with a very small resistance, which is called the shunt resistance, then arrangement this entire arrangement is called as an ammeter, which is used for measuring current. So if I current is the main current flowing through the circuit, so then we have to find out the shunt resistance. So therefore, through the shunt resistance, if Is is the current passing through, so then Is will be equal to 0.9 times I. And this will be equal to, so as you know that current flows, the uh, current is distributed in the inverse ratio of resistances when there is parallel combination. When there is parallel combination, the current is distributed in the inverse ratio of resistances. So therefore, Is will be equal to Rg, means the resistance of the galvanometer, divided by G plus RS into I. So therefore, we can say that G by G plus RS, that will be obviously equal to 0.9. So it means what? That we can say G is equal to 0.9 G plus 0.9 RS. 0.9 RS. So therefore, say that 0.1 minus 0.9 is 0.1 G, that is equal to 0.9 RS. So RS shunt resistance, that will be equal to 1 G by 9. G by 9. It means the shunt resistance is 1 by 9 times the galvanometer resistance. So option 2 is the correct answer. Uh, moving coil galvanometer is converted into an ammeter of range 0 to 5 milliampere. The galvanometer resistance is 90 ohm. A moving coil galvanometer is converted into an ammeter. So the range of the ammeter is 0 to 5 milliampere on either sides, obviously 5 milliampere. The galvanometer resistance G, that is Rg, that is equal to 90 ohm, and the shunt resistance Rs has a value 10 ohm. It means the galvanometer G has resistance 90 ohm and shunt resistance is connected Rs, that is 10 ohm, and this is acting as an ammeter. If there are 50 divisions of the galvanometer turned ammeter on either sides of 0. So here we have on either sides of 0, we have 50 divisions. Here also 50 divisions. So then the current sensitivity of the galvanometer is. So we know that current sensitivity of the galvanometer, current sensitivity, that is given as phi by I, means the amount of deflection per unit current. Or I can say that so it is equal to the total number of divisions, the total number of divisions divided by the current range, the range of current which it can be measured. So the total number of divisions, that is equal to 50 divisions divided by the current range, that is 5 milliampere. So that is 5 into 10 power minus 3 ampere, and this is 50 divisions. So this will be 5 tens of 50. So here this will be the total number of divisions divided by current range. So, so it will be 10 power 4 divisions per ampere. It will be 50 divisions. So it will be 10 power 4 divisions per ampere. So you go to 5. So the total number of divisions divided by current range. Yep. Here the options are slightly wrong. I think the option B should be 1 into 10 power 4 divisions per ampere. So it means option B will be the correct answer. Okay. Then here it is told that 10 identical cells, each of EMF 2 volt and internal resistance 1 ohm, 10 identical cells of, so it has internal resistance R, EMF is E is 2 volt and internal resistance is 1 ohm, are connected in series. So like this 10 cells are connected in series with 2 cells wrongly connected. It means the 2 cells will be connected opposite like this. Okay. So a resistance of 10 ohm is connected with the combination. Resistance of 10 ohm is a resistor of 10 ohm is connected with the combination. Then what is the current through the resistor? So the current through this resistor we have to find. So it means here the equivalent EMF of the circuit that will be equal to, so 8 of them are properly connected. So it will be 8E and 2 of them are wrongly connected. So 2 minus 2E. So it will be 6E. 6 times E. So that is 6 into 2 volt. That is 12 volt. 12 volt is the equivalent EMF. And R equivalent will be equal to 10R plus 10 ohm. So that is 10R, that is 10. R is equal to 1. So 10 plus 10, that is equal to 20 ohm. So therefore, the current will be equal to 12 volt divided by 20 ohm. That is equal to 2 tens are 2 sixes. So that is 0.6 ampere. So option A is the correct answer. Then here it is told the equivalent resistance in between the points A and B in the following circuit is, the equivalent resistance in between the points A and B in the following circuit is. So here we can say, let's suppose that Okay, let's suppose this part is 2 ohm. Now this will be, let's suppose 2 ohm. This part is 2 ohm, and R equivalent of this entire part will be R. Suppose this is again 2 ohm. This is again 2 ohm, and this is also equivalent to across A and B. We have 2 ohm, and this one is again R. This one is 2 ohm. This is A, B. This is A. Okay. So therefore, here R equivalent for this and the R equivalent for this would be the same. Be the same. So here R equivalent is, therefore R equivalent here we can say this is 2 plus R plus 2, that is 4. And that should be also same as this will be equal to 2 plus R plus, so R plus 4. So this is R plus 4 and this is 2. So they are connected in parallel. So this will be R plus 4 into 2 by R plus 6, and then this plus 4. So this will be R plus 4 minus 4, that we can say this will be equal to 2 into R plus 4 divided by R plus 6. So 4 and 4 will cancel. This will be R into R plus 6. So R square plus 6R, that is equal to 2R plus 8. So therefore we can say R square minus 4R, no, plus 4R minus 8, that is equal to 0. Therefore the resistance R, therefore R will, the R equivalent, the R will be equal to, so the R equivalent we have to find, which is equal to R plus 4 actually. R plus 4 we have to find. So R will come from here. We can see that R will come uh, minus B plus B square, B square 16, B square minus 4AC. So 4 8 the 32 by 2A. So this will be equal to minus 4 plus root over 48 divided by 2. So this will be equal to minus 2 plus the 16 3s are 48. So 4 root 3, 4 root 3 by 2, that is 2 root 3. So this will be 2 root 3 minus 2. Now therefore R plus 4 is the R equivalent. So that will be equal to 2 root 3 minus 2 plus 4. That is equal to 2 root 3 plus 2. 2 root 3 plus 2. So that will be 2 into 1.732 plus 2. So that is 2 3 is 6. 2 sevens are 14. And the 2 3, 3.46 plus 2. That is 5.46 ohm. Approximately 5.46 ohm. So it is 5.5 ohm, we can say. So option D is the correct answer. Here it has been told that the resistance of a carbon resistor is 4.7 kilo ohm into 5%. No, yeah, plus or minus 5%. So this is the tolerance. So this is actually 4.7 into 10 power 3 plus or minus 5%. This much ohm. Okay, so this much, this one is the tolerance. So this one is the third band and this is the fourth band. So third band is showing 3, 10 power 3. So it means we know that it is BBROY, GB, VGW means white, black, blue, red. So for black, the so The third band shows the multiplication factor, the multiplier. So for black it is 10 power 0. For okay, so this is brown, black brown. This is 10 power 1. And for red it is 10 power 2. For orange it is 10 power 3. So 10 power 3 is orange. So the answer will be orange. The third band will be orange. So option B is the correct answer. Then the four bands of a color coded register are of the colors gray, red, gold, and gold. So gray, so we know that BBROY, GB, BGW, white, gold, and silver, and then no color. Gold, silver, and no color. So so the first one is gray. So it is black, brown, red, orange. So it is black, brown, red, orange, yellow, and then this is green, then blue, violet, gray, white, gold, silver, no color. Okay. So it will be, so this is 0, black is 0, brown is 1, red is 2, orange is 3, yellow is 4, green is 5, blue is 6, then violet is 7, gray is 8, white is 9. For gold and silver only shows the multiplier, multiplication factor. For black it is 10 power 0, for brown it is 10 power 1, like that. And for gold it will be, it is gold it is 10 power minus 1, and for white it is 10 power 9. For gold 10 power minus 1, for silver 10 power minus 2. And the tolerance for gold it is 5% plus or minus 5%. For silver it is plus or minus 10%. For no color it is plus or minus 20%. So therefore here the colors that is shown, this is gray, and then this is red, then gold, then again gold. So these are the four bands. So for gray, it will be 8. For red, it is 2. So 82 into 10 power minus 1. Since why the third band is gold, which shows the multiplication factor. So this much ohm plus or minus 5%. Since the fourth band is also gold. So 10 power minus 1 means 1 by 10. So this will be equal to 8.2 ohm. 8.2 ohm plus or minus 5%. So option A is the correct answer. Then here it is told where of resistance R is connected across a cell. Where of resistance R is connected across a cell of EMF E and internal resistance R. The current through the circuit is I. In time t, the work done by the battery to establish the current I is. In time t, the work done by the battery to establish the current I is. So the work done is equal to the the energy consumed. That is equal to the electrical energy consumed, which will be equal to um, okay. So which will be equal to E into I into T. E into I into T, work done. So here we know that I equals to E by R plus R. We can say it will be E square by R plus R into T. That also we can tell. So E we can also write it as I into R plus R. So or we can also write this will be equal to I square into R plus R into T. So out of these three, EIT has been written in the option C. So option C is the correct answer. So it means the work done to establish the current, that will be equal to the electrical energy consumed by the battery in time t. Electrical energy consumed in time t. Or we can say the electrical energy which is supplied by the battery in time t. Okay. So here it has been told for a given electric current, the drift velocity of conduction electrons in a copper wire is V. For a given electric current, the drift velocity of conduction electrons in a copper wire, the drift velocity of conduction electrons, that is Vd, that is V, and their mobility is mu. When the current is increased at a constant temperature, when the current is increased at constant temperature, Vd decreases and mu. Okay. So it is told that the temperature remains the same. Temperature remains the same, so the drift velocity will not increase. So the drift velocity will remain the same. The current is increased. Current is increased. So I we know that is equal to NEAVD. So here mobility so here it means when I is increased, it means I is directly proportional to the drift velocity and mu, which is the mobility, that is equal to Vd by E. So it means when the temperature remains the same, the mobility of the electrons will remain the same, since the mobility depends on temperature. Mobility depends on temperature. So it means if since current is increased, so the drift velocity will also increase, and since the temperature remains the same, so the value of the mobility will remain the same. So Vd increases and mu remains same. So option C is the correct answer. Then here it is told a wire of resistance 3 ohm is stretched to twice its original length. A wire of resistance, the resistance of this wire is 3 ohm, and it has been stretched to twice its original length. So it is stretched to twice its original length. The new resistance of the wire will be. Where is stretched to twice its original length? Okay. So we know that R is proportional to L, since R equals to rho L by A. So if the area of cross section is kept constant, so then therefore the length has been increased to twice its length. So the resistance also will be increased to twice of the original resistance. So it will be 6 ohm. So 6 ohm will be the new resistance, since R is proportional to L if the area of cross section is kept constant. So it means option C is the correct answer. In the given arrangement of experiment on meter bridge, if AD corresponding to null deflection of the galvanometer is X, what would be its value if the radius of the wire AB is doubled? So here it has been told that the radius of the wire AB is doubled. This length is X. So here it means the resistance per unit length will also increase. Radius is doubled, okay. So R is proportional to 1 by A. So area equals to pi r square. So it means that R is proportional to 1 by r square. It means if the radius is doubled, so it means that R will change to 1 by 4 times R. Okay. It means the resistance per unit length will also decrease by 4 times. So, so initially the resistance of this part AD, so RAD initially it was R naught into X, suppose, if R naught was the resistance per unit length. So now R naught will decrease to R naught by 4. So therefore, the resistance, let's say okay, R naught by 4 into X, then the new value of this part AD will be R naught by 4 into X. And the resistance of this part dB initially was R naught into 1 is 100 minus X. If it was X is in centimeters, suppose. Okay. So therefore, the new value of RdB, that will be equal to R naught by 4 into 100 minus X. So it means the ratio will remain the same only. Means R1 by R2. Initially it was RAD by RdB. 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 That was equal to X by 100 minus X. and the new value that will be also r dash ad rad dash by rdb dash, which are the new value of rad and rdb. So that will be also equal to x by 100 minus x only. So it means the ratio of r1 and r2, it is independent of a- the radius, uh, it is independent of the resistance per unit length of the meter bridge wire. So even if the resistance per unit length of the meter bridge wire decreases to 4 times, then also the null point or the balance point will remain the same. So it means option A is the correct answer. And here it is told a copper wire of length 1 meter, copper wire of length 1 meter, and uniform cross sectional area 5 into 10 power minus 7 meter square. It carries a current of 1 ampere. Assuming that there are 8 into 10 power 28 free electrons per meter cube in copper, which is n. N is the number density of free electrons. The number density of free electrons in the wire. So that is equal to 8 into 10 power 28 per meter cube. And how long will an electron take to drift from one end of the wire to the other end? So drift velocity equals to, I can tell, L by T, where T is the time the electron will take to drift from one end to the uh, other end. And we know that I equals to NEAVD. So from here we can find out VD, that is equals to I by NEA, where E is the charge of the electron, that is 1.6 into 10 power minus 19 coulomb. So therefore L by T, we have to find out the time it will take. So L by T, that is equal to I by NEA. So therefore T that will be equal to NEAL divided by I. So n is 8 into 10 power 28 into E, that is 1.6 into 10 power minus 19 into A, that is 5 into 10 power minus 7 into L is 1 meter divided by I is 1 ampere. 1 ampere. I is also 1 ampere. So therefore this we have to solve. So 5 it's a 40. So 16 for the 64. 64 into 10 power 28. This is 28 minus 19, that is 9. 9 minus 7, that is 2. This much second. So this we can say 6.4 into 10 power 3 seconds. So option D is the correct answer. And here it has been told that consider an electrical conductor connected across a potential difference of V volts. Electrical conductor is connected across a potential difference of V volts, and let delta Q be a small charge that is moving through it in a time interval delta T. If I is the current flowing, electric current through it, so then I obviously that will be equal to delta Q by delta T. So then, so it means that when this charge will flow, then its electrical potential energy will decrease by an amount IV delta T. Since why we know that the electrical power consumed, electrical power consumed, that will be equal to VI, V into I. So therefore, electrical potential energy, or simply I can say electrical energy consumed, or electrical potential energy consumed in time t, in time delta t, that will be equal to Vi into delta t. And this much electrical energy consumed will result in the increase in thermal energy of the conductor, which is according to the Joule's law of heating. So according to the Joule's law of heating, you can say, according to Joule's heating effect of current, we can say, according to Joule's heating effect of electric current, you can say that this Vi into delta T will be also equal to the thermal energy, which is increased in the conductor. And the kinetic energy of the charge will not increase, since the drift velocity of the electrons will remain the same if the temperature remains the same. Okay. So the drift velocity will remain the same since the current I is not changing, since the current is remaining the same. So it means only the statements 2 and 3 are correct statements. So option D is the correct answer. Then here it is told the resistivity of a semiconductor at room temperature is in between. So it will be 10 power minus 3 ohm centimeter to 10 power 8 ohm centimeter. So it is the range of the resistivity, which is rho, resistivity of semiconductor, which is in this range. Okay. So option D is the correct answer. Then here it is told 10 identical cells, each of potential E and internal resistance R, are connected in series to form a closed circuit. Closed circuit has been formed. An ideal voltmeter is connected across three cells. Across three cells, an ideal voltmeter is connected across three cells. So it will read how much voltage. So the voltage will be equal to 3E minus IR, I into 3R. Since the equivalent resistance across these three cells will be 3R, and the equivalent EMF across these three cells will be 3E. So now we have to find out I. I will be equal to 10E, which is the equivalent EMF of all the 10 cells, divided by 10R. So that is equal to E by R. So therefore, the V will be equal to the the voltage reading of this ideal voltmeter will be 3E minus E by R into 3R. Okay. Ideal voltmeter which is connected across three cells. Okay. This will be 10E divided by 10R. So that will be equal to E by R. E by R current is flowing. Mm. So the potential difference across these three cells will be I into 3R only. So which will be equal to E by R into 3R, which will be equal to 3E. So option D is the correct answer. Then it is told that in an atom, electron revolve around the nucleus. In an atom, electron is revolving around the nucleus along a path of radius 0.72 angstrom, making 9.4 into 10 power 18 revolutions per second. Then the equivalent current is E is equal to this. So it means here charge is moving in some time t. So here we can find out the time period of revolution, which is equal to, so in 1 second it makes 9.4 into 10 power 8 revolutions. So the time required to make one revolution, that will be equal to 1 by 9.4 into 10 power 8 seconds. Since y, this is the frequency of revolution and t is equal to 1 by nu. And so the equivalent current I, that will be equal to the charge by time. So the charge that is flowing at is E by T. So that will be equal to E into nu. So that will be equal to E 1.6 into 10 power minus 19 into 9.4 into 10 power 18, 10 power 8, 10 power 18, sorry. So this much ampere it will be. So this will be 9.4 into 16, 4 into 1.6, that is 16 4 is 64, 16 9 is 144, 144 plus 6, 150. That will be 15.04 into 10 power minus 1 ampere. So it is 1.504 ampere approx. 1.5 ampere. So option D is the correct answer. Then here it is told, when a metal conductor connected to left gap of a meter bridge is heated. When a metal conductor that is connected to the left gap of a meter bridge. So here we have two gaps and here we have the balance point. So when this part is heated, if this part is heated, so then its resistance, the resistance value of R1 will increase. So it means the balance point will shift towards the right. So option B is the correct answer. Then it is told a charged particle is moving in an electric field. A charged particle Q is moving in some electric field which is 3 into 10 power minus 10 volt per meter with mobility 2.5 into 10 power 6 meter square per volt second. Its drift velocity is, so we know that mu equals to Vt by E. So mobility equals to the drift velocity by the electric field. So the drift velocity will be equal to mu into E. So mu will be equal to 2.5 into 10 power 6 into 3 into 10 power minus 10, this much meter per second. So 3 into 2.5, that is 7.5 into 10 power minus 4 meter per second. So it means here option D is the correct answer. Here it is told wire bound resistors are made by. So the wire bound resistors are made with an alloy of manganese, constantan, and nichrome. Since why their resistance are nearly independent of change in temperature. Since their resistance, since their resistance is nearly independent of temperature change. Dependent of temperature change. So wire bound resistors are made by with an alloy of manganese, constantan, and micro. So option C is the correct answer. Then here it is told if voltage across a bulb, the voltage across a bulb is rated 220 volts and 100 watt. It drops by 2.5% of its rated value. Then the percentage of the rated value by which the power would decrease. So we know that resistance of the bulb will not change. Resistance will be constant. So I can say R is equal to V square by P. That will be equal to constant. So it means what? P is proportional to V square since the R is constant. So therefore, we can say that delta P by P, that will be equal to 2 into delta V by V into 100% into 100%. So therefore, it means it is saying that the so and okay, it means the percentage change in power, that will be equal to 2 times the percentage change in voltage. Percentage change in voltage. So it means since the here the percentage decrease in voltage is 2.5%. So it means the percentage decrease in power will be 2 into 2.5%. So that is 5%. So option A is the correct answer. Then here it is told aware of certain material, aware of certain material is stretched slowly by 10%. Its new resistance and specific value, specific resistance becomes. Specific resistance means resistivity. So the resistivity will remain the same since why it is independent of the shape. It is independent of the shape and size. Dependent on the shape and size of the conductor. So the specific resistance or resistivity will remain the same. And if it is stretched by 10%, so it means that R equals to rho L by A. And it is stretched, it means that we know that area of cross section into length is equal to volume, and volume of the wire should remain the same. So it means that A we can write that is equal to V by L. So I can say it is equal to R, it is rho into L square by V. So it means that R is proportional to L square. Since why rho and V will remain the same. So it means that the we can say delta R by R into 100, that is equal to 2 into delta L by L into 100. Means the percentage increase in the resistance is equal to twice of the percentage increase in the length. So it will be equal to 2 times the percentage increase. So here L is changing to 1.1 times L. So it means R will change into 1.1 square times R. That means it is 1.21 times R. So it means that the new resistance will be 1.21 times of the initial, and the specific resistance will remain the same. So option A is the correct answer. So here it has been told the maximum current that can be measured by a galvanometer of resistance R equals to 40 ohm is 10 milliampere. So it means the current through the galvanometer is equal to 10 milliampere, means 10 into 10 power minus 3 ampere. And it should be converted into a voltmeter. So a very high resistance should be connected in series with the galvanometer. This entire arrangement is called as voltmeter. So therefore, here through this Ig current is flowing. So Ig voltmeter that can read up to 50 volts. So across this entire voltmeter, the voltage is 50 volts. So I can say Ig into R plus G that is equal to so the resistance of the galvanometer, which is G, that is equal to 40 ohm. So Ig into R plus G, that is equal to 50 volts. So therefore we have to find out R we have to find. Since why it should be a very high resistance that should be connected in series with the galvanometer. So R plus G, that will be equal to 50 by Ig, that is equal to 50 by 10 power minus 2, which will be equal to 5000. 50 into 10 power 2, 5000. So R will be equal to 50,000 minus G, that is 50,000 minus 40. So it's 5,000 minus 40. So this is equal to 4960 ohm. So 4960 ohm should be connected in series with the galvanometer. So it means the option 2 is the correct answer. So hope all of you have understood the solutions of all these questions on current electricity. Still any doubts if you have, then please write that in the comments. Uh, and also please install our Sapience Education application, since we shall upload some important questions based on the previous year KCET exam, which shall be obviously helpful for your exam. So thank you everyone. Bye.